Hello everyone. Today we are talking about evaluating a difference quotient. When we have started our chapter here on functions, we were looking at questions like, is it a function or is it not a function? But we also included some examples where we were evaluating those functions. And if I just flip back a page, we did that like here, where we had a very specific input and we found the output. And we had skipped this particular problem at that time because that's essentially what we're doing today. So we are taking a look at what happens if you have an evaluation, but you have lots of functions in there. We call this a difference quotient because difference means subtraction and quotient is the result of a division. So we have not one but two functions, and then we're going to subtract their results and divide by h. So here it is, the function evaluated at this input of x plus h minus the function evaluated at this input of x. All of that divided by h. Now there's a tagline here. This only works as long as the denominator is not a 0, right? That's our domain restriction. So this is listing the domain restriction. The answer is only going to be valid as long as h is not 0. Now where did this come from? It technically comes from the slope formula, which we're not going into great detail now, but if you think about the slope formula is y sub 2 minus y sub 1 over the x's, x sub 2 minus x sub 1. So this is the top part. This is your y sub 2 minus y sub 1. Remember, y is your output, and so is this. This is your output, which is like a y-coordinate of a point. This is your output, which is like the y-coordinate at a point. So we're subtracting the y-coordinates. We're subtracting the outputs. Now you might say, well, where are the x's? Well, the inputs canceled out. So we're not explaining that in detail here, so you'll have to take that on face value. We've got essentially the slope formula, but in function notation. So we're going to use this to evaluate certain functions. So let's look at part A and part B. So here we have our function 3x minus 1. That's a linear equation. There's your input, there's your output. So because that's a linear equation, there's your slope, there's your y-intercept. So we already know the slope is 3. So we should get that result after using the difference quotient because we said this is based on the slope formula. So we kind of already know the result. The trick is, how do we interpret these symbols and apply it to a very specific equation? In a moment, we'll be looking at this parabola, x squared minus 4x plus 7. So that's a bit more complicated than just the equation of a line. We're breaking this up into two steps to kind of make the process flow a little bit more smoothly. So here's step number 1. What we're doing is focusing just on this first part. This is telling us what to plug in. It says take the function, take the equation, and plug in this thing. Whatever you see right here, this is what you have to plug in. So the concept is we're going to take this as our input and drop it in here and here, wherever we see that input symbol. So what that means for us is, there's my input, we just dropped it in right there. F evaluated at this new input of x plus h is equal to, so we have 3 times an input, so there's 3 times my input. Again, what we're doing is we're dropping in this binomial of x plus h. And we have this minus 1 that tags along. So it's the same function, but we have a brand new input. We're going to take that binomial and substitute it in place of x. Let's distribute the 3. So 3 times x, 3 times h, there's the minus 1. All of that is the output. That is describing this piece of the difference quotient. So part 2 now, we're going to assemble all the pieces and simplify the fraction. So here's my long division bar over h, so nothing really much happening with the denominator right now. The result from part 1 goes here in the very first part. So there's my 3x plus 3h minus 1. To help distinguish between these two parts, I often like to put brackets around this output so that we can clearly see the difference between what comes on the front end and what comes on the back end. So what are we supposed to subtract? It tells us right here. Can you find the function with the input of x? Yeah, there it is. They gave it to us. That's the original problem. There's the function with the input of x. What is that function? 3x minus 1. So 3x minus 1 is in that second set of brackets. So now we're going to distribute the negative sign. So we have a 3x plus 3h minus 1. Distribute the negative sign, so we have a minus 3x and a plus 1 all over h. And let's combine like terms. 3x minus 3x, negative 1 plus 1. We're left with a 3 times h, and that's over the h in the denominator. We can cancel the h's out. H divided by h is 1, so 3 times 1 is just 3. That's our answer, which is coincidentally the slope of 3. However, we always have to put this tagline on here. This answer is only valid as long as h does not equal 0. So there's our final result. Be careful. Don't say h equals 3. We're not solving for h. This is the result of the difference quotient. Think of it like the slope. The slope equals 3. We don't say h equals 3. So now let's apply this process to a quadratic. Here we have in the next example, x squared minus 4x plus 7. So here's part 1. Part 1, again, we're focusing just on this first part of the difference quotient. It tells us what to plug in. Take that x plus h and plug it in. Where do we plug it in? Wherever you see that input symbol, here and here and here. So they're getting us ready by saying, here's the function, here's my x plus h that I'm dropping in. That equals, don't think of this like an x squared, think of it as an input squared. So here's my input squared. Again, the input is the x plus h. And then we have a minus 4 times an input. What is our input? That same x plus h. And then there's the constant term of plus 7 at the end. Now we want to simplify this, so we're going to FOIL out this binomial, and then we'll distribute the negative 4 in a moment. Let me rewrite this so that we can have this x plus h being multiplied to itself so that we can FOIL that out. I'm just copying everything else down at the moment. So let's FOIL. So first times first term will give us x squared. The outer terms will give us x times h. That's a positive x times h. The inner terms, that's an h times x, which is the same. So I'm going to shuffle the letters around and line them up so that we have like terms here. And h times h is h squared. Now let's distribute the negative with the 4 to the binomial. So a negative 4x and a negative 4h, and there's the plus 7. All of that is the output of the function when we plugged in the binomial. So as we go to part 2 now, and we're setting up, we'll have a pretty large fraction here. All of this output goes here on the front. So we have an x squared. Now I'm going to combine these like terms right here. So xh plus xh is positive 2xh. Then there's the plus h squared. There's the minus 4x. There's the minus 4h. There's the plus 7. All of that is the output from evaluating the function with that new input. Then we have to subtract. What do we subtract? This thing. It says take the function and plug in x. Well, that's what we already started with. That's my function with x as the input. So we're subtracting the x squared minus 4x plus 7. In other words, we're subtracting the original function from the modified function when we had a different input. Again, we're going to distribute that negative sign. So we have a bit of writing here. X squared plus 2xh plus h squared minus 4x. That should be a minus 4h. That's my typo. So minus 4h plus 7. Now we'll distribute that negative sign, so that's a negative x squared plus 4x and minus 7. All over h. So let's see what cancels out. X squared minus x squared cancels out. A negative 4x plus 4x cancels out. And a positive 7 with a minus 7 cancels out. We are left with positive 2xh plus h squared and a minus 4h all over h. Can we reduce this fraction? Yes. Now be very careful. This is where I see mistakes happen. Sometimes I'll have students who will say, hey, I can divide an h with an h, and I'm just going to cancel out here and leave the other terms unreduced. Be careful. You can't play favorites. You can't play, I want to reduce you, but I don't want to reduce you terms. No, you have to reduce every term the same way. You have to be equal in how you reduce. So if you are going to reduce an h out of the denominator, and you're going to reduce an h out of this term in the numerator, well, then you have to continue and reduce an h out of every term in that numerator. In other words, we're dividing every term by h. So we have a 2x plus an h to the power of 1, and then a minus 4. Now that might not look like a slope, and you're kind of right in the sense that it's not just a number, but this is a parabola. That means your shape is curved. So if you were talking about a slope, the answer is it depends, because it depends where you're at on the curve, because your slope is always different. So in other words, this is not just a number for a slope, it's more of a way to calculate the slope if we had to find the slope. We're not going that far. We're just saying this is my difference quotient, as long as h doesn't equal 0. And we'll stop with those two examples.